All right, in this video I'm going to show you how to design a schematic for a simple LED dimmer. I recorded this video like live, but when I remuxed it and like replayed it, the audio was terrible and it was like shrunk down into it was something corrupted the file and it was terrible. So I'm going to do it here again from scratch. So in order to do this, you first have to have Eagle installed. You need to be logged in. You can see it says Peter Rudder there. You log in with your Autodesk credentials, same as you would with Fusion. Once you're to this screen, you may begin the video. Now, as I do this video, I'm not gonna in teaching, I would pause and stop and let you do it and then check in and then resume. This video is just gonna move forward and I'm gonna try to remind you regularly to pause, do the actions. This is not just a video to watch. This is a video to do with me as I do it. So either like put it side by side with the application as we get going, or maybe use your phone while you're watching it and using it, but you want to be able to do it while the video is going, and to pause me when you need to if I'm going too fast. So with that said, don't continue this video unless you have this, because I'm about to get started from this spot. And here we go. Okay, to start building a schematic, what you need to do is you need to go up to File and click New Schematic. That's what we're creating. So I'm going to create a schematic here. And I'm going to go ahead and make this full screen. Now, in this schematic, if I go up here and I click on one of these, by default, you'll have stuff like this showing up. It probably will look like this by default. And on your screen, especially if it's a district issued laptop, this area, whoops, that area, it's not mirrored, so this area over here might be really small. And so to make it a lot bigger, you just click View and unclick these things. And then it'll be like mine, where I have a giant white area and then just toolbars all around. Okay, so once you're here, this is a good spot to get going, but then there's a couple of other like setup things that just make it operate a lot better. So one is if you go up to Options, again, if you haven't had time to unclick all this stuff, pause the video, do it, and then do this next part. Options, User Interface, and there's a couple things that you can look around this user interface a lot, but the main thing I want to focus on here is the mouse wheel zoom. By default, that's 1.2. For most like track pads, that is way too high. As soon as you just accidentally, it zooms by like scrolling, whatever the trackpad does for scrolling, that's how it zooms. And if you have a 1.2, the default, that is just way too fast. It's a 20% per every little tiny moment. And so just even moving your fingers this far might literally zoom out completely or zoom in completely. And so that's just too fast. So for most student laptops, I change it to 1.05. For mine, I found that 1.03 feels best, but something lower. 1 point and then the percentage that you want to zoom in. Now, I have had one student tell me that they've got one of those mice with the scroll wheel that has click positions, and that 1.2 actually feels fine for those. So experiment with it. And so, yeah, so those are kind of our just setup things, get it to a spot that it will work with us. Okay. All right, now, the big thing and the hardest step whenever designing a schematic is to go find the parts. And that's because the parts aren't just a symbol, schematic symbol, they're associated with a physical part. And so when you go look for a resistor, there isn't just one resistor, there are hundreds, if not thousands, of different resistors available. And so finding the right one is the challenge. And so I'm gonna create videos like this to guide you through that process as you're designing things from the ground up. And in this video, I'm gonna walk you through finding every part. So here we go. The first thing we're going to do is where's the add part section. So here it is. You're going to click add part, and when it first loads, it will take a moment. Now this was quick for me on my computer, but it might take 30 seconds for it to load on your computer. It'll take a little while. But this is the screen, and after this point, when you need to reload it, it'll go quickly because it's been loaded into the system memory. Okay, now we're going to make an LED dimmer. So what we're going to need an LED. So what you're going to do is you're going to scroll down. These menus, these are like folders. Everywhere you see a triangle is a folder with something inside of it. So we're going to scroll down till we get to LED. Okay. And you'll notice that on mine, I'll often have multiples of the same thing, LED, LED, and you won't. And that's because I have different systems, ones that are stock that I don't change so I can use them for teaching, and then others that I can modify for whatever purposes that I'm using. And so that's why I have extra. So whenever you're seeing mine and you're like, I only have one of those things and Peter has 2 or 3 of them, that's why, that's fine. You just use the one you've got. So LED here, I'm going to click the triangle. The triangle opens up a folder, and I'm going to scroll down to the bottom of this LED folder, and I'm looking for these LEDs down here. They're all the same. If you look up there, they're different manufacturers, but they're the same like part. So I'm going to choose the one that's called W49180 because that's the LED we're going to use for this. Okay, and then I'm going to zoom in a little bit so it's a little bigger. Okay, and then I'm going to notice up, there is where did it go? There it is. There's a little crosshair here. That's our 0, point. And I usually like to start a circuit somewhere in that territory, although it's just a coordinate system, so there's your 0. It's not fundamentally necessary. You could start it over here, wherever you want, but I like to start near it. Okay. All right, now we're going to add another part. This time, so that one was found by searching for it through the menu system, but if you know the actual part's name, you can type it in and find it that way, but you have to be really precise. Sometimes you can type in a part's name, but you only put part of the name, and this search engine is not good enough to find the rest of it. So it's a really bad search engine. You have to be really precise or else nothing's showing up. So for this one, the part name, it's a transistor called the MJE182. And when I do that, yes, that does come up. So I'm going to pick the top one here. This is what it looks like. This transistor is going to be used to control the brightness of the LED. Click OK. And where I'm going to put this transistor is just below the LED with a little gap. I recommend as you're doing this with me that you put things in the exact location that I put things, because when we go to wire them up, they'll be already pre-placed in a good spot. Okay? And this is also good when you're building from a schematic of doing the same thing, of trying to line things up so that they match. Okay, there we go. All right, now we're gonna need a couple different resistors. Okay, so I'm gonna go down to the folder called RCL, and RCL stands for resistor, capacitor, inductor. When I open this up, you'll see these are a bunch of capacitors up here. The L stands for inductor. I know I stands for current, so L stands for inductor. And then we have resistors down here. Now, there's a European resistor symbol, which looks like that, and then there's a US symbol. So these folders are identical in terms of the resistors inside of them, but the symbol is different. So we're going to use the US symbol, and we're going to start with, this is the most common type of through-hole resistor that in my shop and just really around the world, as far as through hole is the most common I've seen used. So we're going to use this one here. It's if you can't read the whole thing on yours, you can drag this little slider, because oftentimes it's like this, and so you can't see everything. So I've already dragged mine out, and so that's why I can see everything. So I'm looking for this one here. That's a 0204/7. Okay, I'm going to put this. This is going to help send a signal to control my transistor. So it's going to go there. And then I'm going to go find a larger one, which is going to control the maximum amount of current that can flow through the LED. And because this is going to hold a lot of current, it's going to need to be a resistor that can handle the heat. And so it's physically larger. So this is the one that I'm going to use here. It's the 061722. And now we want to talk about how do you rotate a part, because we're going to put it above the LED, but we're going to make it go straight up and down. There's 2 ways to rotate a part. One is while you're able to move it. See, this is moving. If I right click, it'll spin. Okay. There is another way. So after I've set it down in place, there's a rotate function under the move function, and if I click on it here, it'll spin. But I'm not moving it. If if I move this around, it's not moving. So let me go to the move function here. And this brings me to another thing. If I'm going to grab a part, delete a part, rename a part, I have to click in the right spot. I just can't click anywhere. It doesn't just work anywhere on this part. There is a little crosshair right there in the center. And it's not always in the perfect center of every part. And some parts you can't even see it. On this transistor, you can't see the crosshair. It's right there. There it is. And so sometimes you have to click around. Unfortunately, they made the crosshair the same color, the exact same color as the part, so you can't always see it. Okay. The LED, the crosshair is up here, so if I click down in this area, it won't move. And so there you go. So now I'm getting pretty close here as far as the parts that I need. There's one more like physical part that we need here, and that's going to be a potentiometer. Okay, and so I'm going to go ahead and close these folders and scroll up to, oh, I went too far, to where it says pot. Pot is short for potentiometer. So I'm going to click in there. I'm going to go down to where it says trim US, and the potentiometer we're going to use is a trim pot. It's something you use a little screwdriver to adjust, and we'll use that to adjust our brightness of our light. So we're going to add that in, and it's just going to go like so. Okay, now we have all of the parts as far as we need, like physical components, that we go find one and install it. What we're going to do now is add power symbols to the system. And so those symbols that we're going to use are ground, which you just need to type in A, G, and D. By the way, if you are behind right now, you should pause the video or rewind the video and get caught up. Don't wait till the end of the video to do all this. Do it as I do it. Okay, so A, G, and D will give me this ground symbol that we'll use. Okay, so there's a ground symbol, and we're going to need it here and there. Okay, and then we also need a plus 9 volts symbol. We're also going to need this in 2 places, but I'm going to show you here what happens if you like put it in one place and then later you're like, oh shoot, I want to also get it. Do I have to go search for it again? No, you can just copy. So here's the copy functions underneath the rotate above the trash can delete. So if I click here and click on this, I can just copy it over. Now I'm going to go ahead and use this trash can icon because I kind of have a pet peeve with having the text ground next to a ground symbol. It's redundant. Like, this is a ground symbol. I don't need these words. It's just extra text that's going to confuse me. So I'm going to click this and just delete those. I do keep it for the positive voltage because I don't know what that is. Just by default, I need something to tell me, oh, okay, it's 9 volts here, it's 5 volts here, it's 12 volts there. Okay, and then I'm going to show you this other function up here, a bunch of zoom functions, but the one that is great is called zoom to fit. So if you're like wanting to come back to the whole schematic, you do zoom to fit, and the whole schematic comes back. Okay, now that we're here, we're getting really close. What we need to do now is wire everything up. And there's 2 methods to wiring things up, and I'll tell you the one tried and true that always works, and then one that works in a pinch, or sometimes when you're working around quickly, you can do that. But it is one you need to be careful with because it can look connected when it's actually not. Okay, so the tried and true is this net function, and this is this green capital L on its side. Okay, and I'm going to zoom in here. When you get to any pin, there's a circle that appears, and we click on it with the circle and go to the other circle. Now they're wired up. That's it. And so I can just go and do that all around. Okay, so that's the tried and true method because I can see the circle and I can see another circle, and when I click them both, I'm in those circles. I know I'm connected. The other method that can be used is you can place a part next to another part, and usually it will automatically connect it. But I say usually because there's plenty of scenarios in which it hasn't happened and it looks connected, or you think you put them together, but you actually did something like this. Well, let me grab this. Oh, well, that green wire is gonna obfuscate. Seen students do stuff like this, where that looks like it's together, but nope, nope, not at all. And so I recommend that if you do this method, which you are allowed to do, that you drag the part 1 away so you can see the green wire that connects them, so you can be sure that they're connected. If I don't drag this around and have it follow it, then it's not connected. Okay. All right. So I'm going to stick with the routing with the green wire because it's the tried and true. It's the one that you could be most confident in. Okay. And there we have a whole circuit wired up. This, as a schematic alone, is a functional schematic. The problem is that we have no way to connect power. Like, there's power symbols, but there's physically no power connections. And so we need to add those. So we're going to go over for one more part. And in this course in LED circuitry, one of the most common connector types we'll use is just holes that are 0.1 inch apart. And the place to find that in here is in Con Molex. Molex is a company that makes a bunch of different types of connectors. So all of these Con Dash are connector companies. So Con Molex. And what's nice about this is that the top list is just, here's 2 connections, here's 3, here's 4, here's 5, here's 6, here's 7, and and so on. So however many connections you can just make from this list. Now, you'll notice that there isn't a 1-pin connection, and that's because in order to have a circuit, you have to have something going out and something coming back in. And typically, for a simple circuit, that's power and ground, or signal and ground. Always ground is included in one of those two. That's the 0-volt reference point. It's the return where everything comes back through. Okay, so for this, we just need 2. Click on those 2. I'm going to click anywhere here. And I'm going to then use this move function to drag the top pin to 9 volts and the bottom pin to ground. Okay, now we're going to, so now the schematic is complete. Now we're going to label some things before we get to the board. And so at this point, I would pause before doing this next step until you have all of this, okay? And so this next thing is going to be the value function. So we're going to click the value function. It's right here. There's a name function and a value function. I'm going to click this value function, and then I'm going to click on these things, and I'm going to assign them a value. So for this trim pot, I'm going to assign it a value of 10K. As we get going, there'll be times where you'll determine the value yourself by experimentation. There'll be times where it's just, oh, it's part of the schematic. It's already written in there, so I don't have to think about it. I just put a value in. And so for this case, we're just going to, what am I trying to say? We're going to have you put in the value that I just tell you, okay? All right, let's make this a 1K, okay? And then we'll make this a 22 ohm. Now notice I'm not going to write 10K ohm or 1K ohm or even 22 ohm. And the reason why I'm not going to do that is because there is a resistor symbol right here. And when you have a resistor symbol, you already know that that number is telling you the measure of the resistance. And so you don't see ohms always written. Sometimes it is, and sometimes it's not. Even in professional documentation, it's not always written, the ohm symbol or the farad symbol or the Henry symbol or whatever unit of measure. They're not always written because the symbol tells you what that number is communicating. Okay, we're going to change this LED as well. When I click that, it's going to say, you sure? Yep, I'm going to change that. We're going to call this what it is in the room, which is a 3-watt LED. So I'm just going to go 3 capital W for 3-watt LED. And then same thing for these pins here, this connector pins. I'm just going to change that into 9 volts, as in like a 9-volt battery connect here. Okay, and now this schematic is complete. I'm going to do a couple of other things, like I'm going to go ahead and drag this over here to make it clear what it's about. I often find with transistors, the text is just in some weird spot. And if you're, a little OCD, you can even make it center some things and make it a little more clear, but those are unnecessary. Those are just like makes it easier to read the schematic. I will tell you that one of the exceeding opportunities is to make your schematic perfectly match this one. So all those little details I just did and realignment and everything, like perfectly match every little detail of precision to make it look really crisp and clean. And it's not the only one, but it is one of them. Some of the other ones are to make your circuit board smaller, like I think it's within 1 square inch, and another one is to build and manufacture it and get it to actually work, to actually test the design you come up with. So anyway, at this point, we are done with the schematic. The schematic is complete. We have an LED dimmer. This is the trim pot that's going to change its voltage. When we turn it up, it's going to go towards 9 volts. When we turn it down, it's going to go towards 0. That's what ground is. And so when it goes up, it's going to send a higher voltage to our transistor, which will turn it on brighter. And when it goes down, it'll turn it off and make it go dimmer. Okay? All right, and we'll get to more of that in later times. The last thing we need to do to wrap up this video, to wrap up this phase, is to get our board. So I'm going to get out of this full screen here. I'm going to go up to File and switch to Board. And when I do that, it's going to say, hey, you don't have a board. Do you want to make one? Yes. Okay. And oh boy, oh, that just did something. Okay. Eagle has some glitches for this type of system sometimes. Anyway, I'm not too worried about it. But now I've got my board. This is where this video is going to end. We're not going to do any setup with this board. That will be in the next video. But you want to get here because I wanted to tell you that there are always 2 files that come with designing a circuit board. There's the schematic and the board file. And when you go to save, which I'll find it under File, which you can't see anymore because of the little glitch. But up here I clicked File, and oh wait, that's not File. There we go, File. File, and then there will be Save, or you can just go Control S. And then what you want to do is, Eagle files are not saved in the cloud, they're saved on your computer. So you want to save it in your OneDrive, and to create a folder for this class, I'd call that folder LED circuitry, or even electronic circuitry, if you're in both audio and LED, and you can save all your files in that one place. So I'm going to go to my OneDrive, where's it at? There it is, and to my electronic circuitry. And then when you save it, I recommend that you save it with your name and what it is you are making. Okay. And now when I do that, let me close out of Eagle here and open up my OneDrive. Okay, I'm going to do this quickly because I want to finish this video. OneDrive, electronic circuitry. Okay. If I scroll down to Peter LED dimmer, there's my files, and you'll notice that there are 2 of them. Okay, and there are 2 of them, and anytime I want to change anything, I need to, when I open one of them, both of them will open. And that needs to stay the same. You cannot operate it with one open and then close the other window. Do not do that. You can minimize the other window. You can hide it behind, but you cannot close the other window. They must be both synced, and so they must be both operational at the same time in order to talk to each other. That also means they both have to have the same name. By default, it'll do it for you. You can see here that there's 2 of them. But it also means when you upload the files to submit to the assignment, you need to upload 2 files, not 1. So for this system, those 2 files are acting as one. And you need to, when you open one, the other opens, and keep them both open. And when you save it, they both save. And when you submit it, submit them both. Submitting one is not enough. And so, yeah. Anyway, the next video will cover how to lay out that circuit board and get this project finished.